Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. K2Cr2O7, acidic dichromate, is an oxidizing agent. When a secondary alcohol, or on a ring carbon, is oxidized, it becomes a ketone. Additionally, beta-keto acids, a carboxylic acid beta to a ketone, or more precisely an alpha-keto acid or beta-keto acid, readily undergo decarboxylation upon heating. Moving on to the next step. Identify the starting material. The structure shown is 1-hydroxycyclopentane, 1-carboxylic acid, or 2-hydroxycyclopentane, 1-carboxylic acid. The O and CO2H are on adjacent carbons of the cyclopentane ring, making it an alpha-hydroxy acid. Moving on to the next step. Oxidation with K2Cr2O7 heat. The secondary alcohol, O, is oxidized by K2Cr2O7 to a ketone, giving to oxocyclopentane 1-carboxylic acid, an alpha-keto acid beta-keto acid on the ring, which corresponds to option C. And for the final step, decarboxylation. The heat, delta, condition promotes decarboxylation of the resulting beta-keto acid, alpha-keto acid. Alpha and beta-keto acids lose CO2 readily on heating. The CO2H group is lost as CO2, leaving cyclopentanone. Final product. After oxidation of O to C is equal to O and decarboxylation of the CO2H group, the product is cyclopentanone, a 5-membered ring with 1 ketone group. Why other options fail? A. Cyclopentadiene would require elimination reactions, not oxidative decarboxylation. C. 2-oxocyclopentane, 1-carboxylic acid is only the intermediate after oxidation, not the final product under heating conditions. D. Cyclopentane, 1-carboxylic acid would require reduction, not oxidation. Therefore, the correct answer is B. Therefore, the correct answer is option B.